13, question A mock, and what we're doing is the following. We have a lift that is in continuous descent. However, it does start from rest. Everybody see the underlying term rest to rest? Okay. Now, here's what we're going to do. We're going to go up and we're going to go across. Okay, and what we're going to have a look at here is the following. All right, two ways of doing it. I saw somebody do it this way. I thought it was pretty slick. All right, do you remember the ratio of acceleration to deceleration? Remember that trick? All right, it's a 0.8 ratio is to 0.6. Okay, and what somebody said was that what happens is the lift accelerates and then it decelerates. Which time is shorter and why? Oh, I did it wrong. Which time is shorter? Can you tell me? The way up or the way down? Or not so much the way up, but you're speeding up versus you're slowing down, all right? So we cap it off at V. Now, I believe that this line here, this yellow line is shorter. Can anybody say what has drawn me to that conclusion? Why is it slower? Why is it shorter amount of time? Greater acceleration. Agreed? And this one is a slower amount, yeah? Okay, we've established that. Now, somebody was smart enough to do it like this, and I thought it was very slick, well done. What he did was he reversed it, all right? So what he says is T1 and T2. He went T1 is, T1 would be 0.6 of the time, which is a shorter amount of time, as predicted. And he goes T2 would be 0.8 of the amount of time. Add them together, what happens when you add the two of them together? 1.4 T. And how long is 1.4 T? 21 seconds. Divide 1.4 T by T by 1.4. Divide 21 by 1.4. Anybody? 15. Okay. And here's the deal. Then multiply your 15 by 0.6. 15 multiplied by 0.6 because it's 0.6 T. That's 9 seconds right there. And what does that make the blue section then? Makes the blue section 12. Is that okay with you guys? 9 and 12. Now, the way I sort of did was I actually did a ratio of 4 is to 3. See the 0.8 and the 0.6? I divided the two of them into each other and I figured out that it's 4 is to 3. And the way I would have done it was I did 3T for the first section and 4T for the second section. What happens when I add 3 and 4 together? What happens when I add 3 and 4 together? 7T. And then 7T would be 21, which means my T would have been what? 3. And then I did the same thing. I multiplied 3 by 3 to get 9, and then 4 by 3 to get 12. How many people got 9 and 12 respectively? Okay. Next question. How many people had the 9 and the 12 in a different order? It was 12 and 9, wasn't it? Yeah, so you should have known it. The first one was the shorter amount. Okay. So, okay. We all good there? Now, what's the next thing it wants from us? Find the total distance ascended. No hassle. We're about to find the height of the thing is V, isn't it? We have two methods available to us. We can use phi equals u plus at. So what's phi equals u plus at, lads? So we start off at what? Start off at 0, don't we? What's our acceleration? 0.8. What's our time? 9. And a v value of? What is it? 7.2, right? Now, if I want to get the area of this entire triangle, what do I need to do then? A half base times height. A half base times height is the entire distance covered. So I think it's 21 for the base, and the height is 7.2. Okay. So what's a half 7.2 times 21? I believe it should be 75.6 meters. Now, okay, car in a van rests on straight horizontal road with the fan 25. So look, we're going to draw ourselves a little diagram here. Here's your car, and here's your van. Okay? Somebody wrote down the times are equal. No, they're not. It clearly says one of them starts 5 seconds later. Okay? So they're not equal. The times are not equal. Okay? Now, what we have is your initial 25, and a lot of you forgot about that initial 25 distance. Just forgot completely about it. Okay? Now, what's going to happen is the fan will travel to a new position, all right? So the fan moves off with an acceleration, and 5 seconds later, the car moves off in the same direction. They both start from rest, don't they? Now, here's what's going to happen. The fan starts off, and the fan ends up down the road. And for argument's sake, I'll call this distance X. Is that okay? Now the car goes all the way down the road, and it's at the point where it catches up with the van. You see the way they're both on top of each other? And for argument's sake, I'll call this distance Y. Is that okay? So what I'm saying now is that Y has to equal X plus 25. Do you see that? Y equals X plus 25. The distance covered by the car is the same as the distance covered by the fan, plus an extra 25 meters. Is that okay? Now you're going to do UVAST for both of them, and most of you are really good at this. You did UVAST quite nicely. Okay, and we're happy with our UVAST. So let's start off with the van. The van's going to be the black one. So it starts off at 0. What's its acceleration? 1.5. Its distance is? What distance does the van cover, letter-wise? Which one? X. T value? Do we know? No. It's traveling for 5 seconds longer, isn't it? So call it T plus 5. Somebody else used a T and T minus 5. That's okay. The system will still work. Okay. Now, what about the second one? This is the car. Now, what about the car? U is 0, V. Anybody? We don't know, sorry. A, 2, S. What's S, lads? What letter? Y. T. Just T. Now we're in business, okay? Now, should I use phi squared equals u squared plus 2ac? No, v value, right? Bad choice. Anything with v is a bad choice. What's the only thing that's left over? Ut plus a half. At squared. You cool with that? Okay. Now what do we do now? Let's start off with the van, which is x. So x equals what's ut? U multiplied by t. 0 times t plus 5, yeah? A half. What's a? 1.5. And then after that, t plus 5 squared. Cool. Okay. Now, a half times 1.5 is 3/4. And I'm going to square out the t plus 5 squared to get t squared plus 10t plus 25. Yeah? Now I'm going to go for the y value now. You see the y value? Okay. Y value. Once again, ut is going to be 0 times t, and then it's going to be a half, 2 times t squared. Then we get y equals t squared. Go. Okay, next part. And this is, a lot of you's got this far. And I was like, yeah, we're in business. And then what happened? Where did this go? The 25 just disappeared, right? That's what happened to you. Okay, so we're going to have to set up this equation. See this equation I have on top? I'm highlighting here. We're going to have to set that up. Y equals x plus 25. Okay, so that's what we're going for now. So y, which is t squared, equals x, which is 3/4 T squared plus 10t plus 25. And then plus your 25. Going to multiply both sides by 4. Is that okay? That will get rid of the fraction. Some of you guys are crazy for doing decimals and stuff. There's a lazier way. Just get rid of the fraction. Not dealing with decimals today. And then multiplying by the 3. 3t squared plus 30t plus 75. What has to happen to this 25 here? What has to happen to it? I multiplied both sides by 4 to get rid of the fraction. So what is it now? 100. Okay. Okay, going to bring everything over to one side. We're going to get t squared, because 4t squared take away 3 squared is t squared. What do we reckon then? Minus 30t, yeah? 175. Is that right? Minus 175? Okay. Yeah, it is right. Two answers then. T plus 5 and t minus 35. So this means the following: t equals 35. So the car was traveling for 35 seconds, but the van was traveling for 40. Now, next thing. How fast would the car be ahead after a further 20 seconds? Most of you had a great idea for this. And here's the idea you came up with. And I liked your idea. You go back to your initial setup. Right? Do you see this? Just get rid of that. Get rid of that. Did we all agree that it's going? The van is 40 and the car is 35. Everybody agrees with that? Fast forward 20 seconds into the future. I think I have a quicker way of doing this. What's 20 seconds in the future? Huh? 60 and 55. Okay. Now there is a trick here. There was one person who did this, but you forgot the extra 25. That's what got you. So what I'm going to do is I'm going to figure out how far the van traveled, and then how far the car traveled. I'm going to compare the two of them. Okay? So let's go for the car first, or sorry, the fan first. So ut plus a half at squared, 0 times 60, plus a half 1.5 times. Will somebody throw that in the calculator? Really quick. Is it 2,700? All right. Now, next one. 0 times 55. Do you see that? And plus a half 2 times 55 squared. Go on, somebody throw that in. Let me know. Prediction time. Are we expecting it to be bigger than 2,700 or smaller than 2,700? It's the car. The car caught the van, overtook the van, and traveled another 20 seconds down the road. It's got to be bigger. 3,025. Excellent. Now, here's the deal. The answer, if I took the two of them away from each other, it's 325 meters. Somebody's like, I got that. You did me. No. There was an extra 25 that the van started off with. Remember, the van had a 25-meter head start. So you take away 25 and you get 300 meters start.